So here are the test tubes with the cobalt complex in it that we're going to apply Le Chatelier's principle and see which way it shifts to get the two different colors of our two complex cobalt ions, one with water and one with chlorine. We'll use the back test tube as our color reference every time. So in our first test tube, we're going to add water until we see that we definitely get a purple color.
Oh, what? That's kind of more pink.
So we added water to test tube number 1 till we got it to a purple color, and we're going to leave this as our second reference. So we have our first reference that was made in 95% ethanol solution of our cobalt 0.3 molar cobalt chloride hexahydrate. Okay. And then we added water to the first one. Now in the second one, in our series of 6 test tubes, we are going to add
a few drops of silver nitrate solution.
We're going to add some silver nitrate solution and see what happens. Okay, so we're adding 1 molar silver nitrate solution to our cobalt complex.
It's looking more blue. Oh wow.
It's getting a little cloudy, telling us we're getting some precipitate in there.
Huh. That's crazy.
So you can definitely see precipitate. Right, and it's shifting the color.
I'm going to keep on going until it gets pink.
So we're definitely seeing it shift toward the pink side, and we do have that precipitate in there. So by adding silver nitrate, we're causing a shift, and we're causing a shift because we're getting a precipitate. Oh yeah, it's definitely pink. And we've got that nice precipitate in there because it's that opaque. And if you pick it up, pink solution on top.
And you can see it really
at
the bottom there.
There you go. There's your white precipitate, and then you have your pink now complex on top. Nice. Okay, so by adding silver nitrate, you are actually reacting the chlorine, okay, because then the silver reacts with the chlorine and forms a precipitate. So what in essence it's doing is it's pulling out the chlorine, so it's removing reactant. And by removing reactant, then you need to think about which way it's going to shift. Okay, does it shift back to make more reactants, or does it shift to products when you remove a reactant by adding silver nitrate? Okay, so now we're adding water to the third one till we see which way it completely goes. All right. Oh, and there we go. So adding water shifts us completely pink away from the blue. So we have the one reference here. Where's my finger? Okay. Where we added some water till it got to purple. We know what it looks like originally here with the blue. Here's our silver nitrate added, so we get that same pink color, right? So these two have to be shifting in the same direction because you have the same pink color, but by doing separate things. This one, right, reacted with the chlorine, so it's removing reactant. Water on your equilibrium is on the right-hand side, so you're adding product. Okay, so to test tube 4, we're adding concentrated hydrochloric acid to see if we get a color change. Which way does the color go? So it looks like, right, it's staying in that blue range. We're not seeing purple. We're not seeing pink. So adding concentrated hydrochloric acid, right, keeps us to the blue. Yeah, no purple, no pink. That's 12 molar hydrochloric acid. So it's shifting to the blue. so it stays blue. Test tube 4 added concentrated hydrochloric acid, and it stayed really blue. It has no purple hue. All right, so it's towards the blue side by adding hydrochloric acid. So you're adding hydrogen ions and chlorine ions. So on your equilibrium that you have on your paper, right, you look to see are any of those ions on your paper, and chlorine ions are. So in essence, you're adding chlorine ions. So you're adding reactant. So we're placing test tube 2 and test tube 6 in the ice water bath to see if we see a color change happening. Right, so we're going to watch them to see if anything happens in the ice water bath. So they've been in the ice water bath for a few seconds. We'll leave them a few more. What we're seeing is that the test tube that was purple, right, is turning really pink. And this test tube over here that was really blue, right, it's kind of staying blue. It might be turning a little purple. It's really hard to tell because that was really, really blue. It's very, very concentrated. Okay. All right. So now we're going to take what we think is our pink and put it into our warm water bath. So we stick our, what was pink, into our warm water bath, and we can see at the top, it's definitely turning blue, back to that purple again. Oh yeah, we're definitely getting blue color. Oh yeah, it's turning really blue in the heat. Okay, so adding heat turns it blue, and we can go back into the ice water bath with it, because we've turned it really blue with that purple on the bottom, and then see how it turns in the ice water bath. Yeah, you can see on the bottom it's turning really pink. So ice water shifts it to the pink side, warm water shifts it to the blue side. So in an ice water bath, you're removing heat, and in a hot water bath, you're adding heat. So from that, you're going to decide, should heat be a reactant or should heat be a product, so you know whether this reaction is exothermic or endothermic by the way the temperatures are shifting it. Yeah, so we're turning much pinker on the bottom with the purple on the top.